So hello, and welcome to our session. We're going to be talking about current coding during COVID and how we ran virtual 4-H clubs for youth in West Virginia.
The two of us who are talking today, my name is Kati Baker. I'm the West Virginia University Extension Service computer science innovator. So I run a lot of workshops and events throughout the state, encouraging and teaching STEM to youth.
And my name is Emma Gardner, and I am the Roane County 4-H Extension Agent. I have a real passion for STEM education, so I try to work myself into any computer science or STEM programming that we have statewide and locally. So we're going to go ahead and get started and talk about how during what happened to our computer science program basically during the COVID-19 pivot. So back in 2020, starting at the end of March, which is actually, I got hired at the end of March, or my start date was at the end of the March. Was yours also around then, or was yours in April?
Mine was April. So yeah, we started about the same time, basically. Yeah. The pandemic started.
Yeah, we started, the two of us started in the pandemic. And so we had this idea of what our jobs were going to be like. And then everything basically shut down. So there was no in-person summer camps, no club events, none of our like workshops or in-person events that 4-H usually has scheduled was happening. So we knew that the kids were already in virtual classroom sort of situations. They were meeting in Zoom and on Teams and all these things. So we really wanted to offer some kind of computer science and STEM hands-on programming. And we wanted to offer it across the state, knowing that we could have kids online from anywhere in West Virginia with internet service. So what we did was we decided to come together and present basically a computer science club that would meet twice a week. So next slide, please, Kati. So we had 2 sessions of Scratch coding clubs, and they would meet twice a week for 1 hour. So I think we did Tuesdays and Thursdays. Correct me if I'm wrong. And this was tough because we would do, I think we did like 1 o'clock and then 3 o'clock. And we would just like basically our entire month of May. And then June was basically eaten up by these coding classes. So we had them meet twice a week for 4 weeks in the month of May and the month of June. And we had over 500 kids up, 500 kids sign up for these clubs. And then in July, we ended up hosting standalone workshops that were about 2 hour long, and they were on all kinds of different subjects. So we used TinkerCAD, Code.org, Scratch, and CS First game development. So we had in total 40 club meetings and 8 one-shot workshops. Do you have anything to add about that, Kati? I know we had a ton of kids.
Yeah. I think it was a little less than 500, but we only anticipated having 50 kids. We had only planned to do a sort of one-shot workshop once, but there was so much interest across the state that we ended up getting hundreds of kids, which is why we ended up adding more sessions for these Scratch coding clubs and then adding even more things in July. So response was overwhelming.
Yeah, we ended up having, I guess, 5 instances of these 4-week clubs, which were giant groups of kids. So it worked out really well, and we were really pleased with it. So let's talk a little bit about how the typical session went. So at the beginning of the sessions, we would do a pre-knowledge survey. So this usually entailed like a basic 5 questions about what sort of like some basic computer science things. So, what do you call a problem in the code? And then it would be like bug and, 3 other options that were probably also animal names that were not bug. And then we were like, we tried to test them on that. And I think we had a question about loops and about if-then statements and, your really basic computer science education topics for our pre-knowledge survey. And then at the end of the clubs, we gave the same 5-question survey. And we just wanted to see if they learned the answers over the course of the club. We would also showcase previous lesson projects. So this was really cute. In the beginning of our Scratch project or our Scratch clubs, for instance, we would showcase, you can see in my image that I have there, this is our Scratch studio for our May Club, and it has over 100 projects that the kids had shared to it. And it was really great being able to show their projects at the beginning of every club meeting, and they would be like, oh, show mine next. You have to show mine. And this really became my favorite part of the club, because it would be whatever they had worked on since our previous meeting. And then they were just so excited to show it off and talk about all the choices they made. And it was really cute. So I loved that one. Then we would usually start out by checking to make sure that everyone still had access to the platform. So lots of times kids would lose their passwords. This was more a problem towards the beginning of the workshops, and it became less of a problem as the workshops went on. But that was, a little bit of a learning curve on that. But as the kids got used to it, they didn't need it anymore. So next we would introduce our new topic, and we would talk about what we were going to do for that day. So if we were using, some of our platforms had videos, so we would show some of our videos then. And some of our platforms did not have videos, so we would just discuss it with them. We'd make sure that we would teach new computer science terms and reiterate any of the terms that we had learned during the previous session. And then the next step would be to go through the coding project step by step. So if this was a project that had videos, we would play the video for the kids. And then after the video was over, we would open up the coding platform and we would reiterate the exact same steps that they had done in the video and make sure that the kids were following us. There's often questions during this part where they would want us to stop or slow down, and we would be happy to do that. After that, we would take time to answer any concerns and questions from participants. And sometimes they would have pretty interesting questions like, how can you do this really wild thing that we frankly had no idea, but we would always say, we will find out for you and get that to you by our next session. So that usually worked out pretty well. And one last thing is we would record our meetings and make sure that we emailed them out to participants afterwards. This was actually something that parents really enjoyed, and we got several comments on our evaluations that they appreciated this if they had to miss a session or if their kid was interested in going over a place that they had maybe misunderstood earlier.
Yeah, and I would just like to add that it also made it really accessible to kids throughout the state, especially those that have really spotty internet, or maybe they lost internet connection, or maybe a storm passed through and they lost power for that day. So the recording the meetings was super, super important for us and the kids. And one last thing, when Emma talked about going through these coding projects and having kids ask us questions, and we said we don't know, but we'll find out. That's also another big part of what we tried to demonstrate and model in these clubs, was a growth mindset and making sure that kids, understood that it's okay to not know all the answers, but it's important to have the willingness to go and find out about it.
Absolutely. That is so important. And one more thing on the recordings is sometimes, we would do 2 or even 3 sessions a day. So we would just hope that we got one good recording session, and sometimes we would forget one, and we would just send out the one good recording to all the groups, and that worked out really great.
Yep.
All right, so now I wanted to briefly talk on our platforms that we use during this. So for the most part, we were using Scratch and CS First, but in our July sessions, we also touched on, in addition to Scratch and CS First, we did TinkerCAD, which, CAD is Computer Assisted Design, and Code.org, which is a international coding platform. So let's talk a little bit about each one. So Scratch is a free programming language that was developed by MIT. It is designed for youth aged 8 to 16, but it's used by people of all ages. Before I got my job and I was a 4-H leader, I worked with the Girls Who Code, and Scratch was one of our most common coding platforms because it's so simple to pick up. And it's just really wonderful to use, and it can do really complicated things. So it's a drag and drop coding language like Blockly, and it has a really low floor, which means that it's simple to get started in, but it has a high ceiling, so you can do some really complicated things. It also has a wonderful virtual community. You saw in that previous slide where I had shared a Scratch Studio where the kids were able to share their projects. There are all kinds of Scratch studios, and you can comment on them and share them and just look at people's work as long as they've made it publishable. And it's just a wonderful platform. I really love Scratch. There's some really complicated things you can do with it, or you can do really simple things like draw a cat and make it walk across the screen, or you can do really complicated things with variables and all kinds of stuff. So I really love Scratch, and I definitely think that not just kids, but adults should have a chance to play with it and learn from it. It's a great platform. So the next platform we used was CS First, Google CS First, and it has really easy to use computer science curriculum. You just go to the website, you can just Google CS First and it'll take you there, and there's a login that's really wonderful. It has these step-by-step videos, which I touched on earlier, and it partners with Scratch to do coding. So the target ages for Google CS First is 9 through 14. And it offers both standalone lessons. So there's one called Animate Your Name that's really popular, or it does multi-lesson units. So the one that we did for the most part was this game design one. And it had, I think, was it like 10 units total? And we tried to get as many as possible in. The videos are wonderful because it has real people, and often they bring in additional experts to teach these computer science concepts, such as events, loops, if statements, and variables. And they're organized into these classes. So you sign into Google CS First, and it's kind of like a Google Classroom setup, and it gives you their Scratch username and password, and it lets you check on their account and check on their progress. And it's really, really wonderful. It's a great setup, and it works really well with Scratch. So I love Google CS First, and I'm glad that we had the opportunity to use it.
Yeah, and I'll just add a quick note here that after the summer, in the fall, we did run a 2-day workshop for educators in the state in how to use CS First and Scratch. And we will include a link to those recordings and those resources at the end if you are interested in learning more about these platforms that we're sharing.
Yeah, absolutely. And we have all kinds of great information in that video. It was a 2-day workshop. So we had a lot of information on how to create an account and how to organize the classes, as well as how to use the platform itself and how we suggest teaching it online. So those are great workshops that we did. Absolutely. So our next slide, we're going to be talking about TinkerCAD. So TinkerCAD stands for, like CAD stands for computer assisted design. So they're much more complicated, and it's a simplified one that is meant for lay people to use. So not just children, but it is definitely targeted at children. So the TinkerCAD education offers 3 main platforms. So they have 3D computer assisted design, which is basically any CAD platform where you're just building things. And you can build all kinds of things. I've built rocket pieces in it before. There are all kinds of options you can do. I did necklaces and earrings for a club once, and that worked really wonderfully. We did not do that this summer, though, or I'm sorry, last summer. There's a platform to do electronics and simple circuits or programming Arduinos. I have not personally played with that, but it looked really cool on the image there. You can see it's that very bottom picture, and it's just a really nice little programming setup. And then we used, for our workshop that we did in July, we used CodeBlocks coding to produce 3D models. So we did drag and drop coding, which then produced a charm bracelet, right, Katie?
Yep.
Yeah. And it was through a hour of code program, and it was really wonderful. So I love TinkerCAD. There's freedom in TinkerCAD to either set up classes or just have the kids create their own accounts for single use, which is really nice. So if you want to do a more complicated class setup, if you have maybe a long-term club instead of a one-off workshop, you can do that. That's really helpful. There are also lesson plans available in all kinds of subjects, not just computer science or design even, but they've got engineering, math, robotics, science, tech. They have language arts and history. They have all kinds. There's also several self-led hour of code activities available that you could just share out. And it's just a great art program to just play in if you wanted to do the 3D CAD system alone. It's just wonderful to just play with and do art in. And then last is code.org. So code.org is really an all-encompassing coding website. It's got classroom lessons. It has one-offs for clubs. It has workshops. It has just hour of code activities that are just great to play on. I really, really love code.org. And what's great about it is everything is in one website. So it has standalone lessons, or it has multi-lesson courses that teachers can set up and have their students participate in. It also has multiple coding languages and is set for multiple age groups. So it really is a K through to college program, and it's really wonderful, and it's free. The best thing about code.org is that it is free, and they have training opportunities. So Code West Virginia is the WVU sponsored coding I guess, group. And what they do is they partner with code.org to provide training for elementary school teachers that's over like any time during the year. And then they do it with high school and middle school teachers, and they do like a week-long training opportunity over the summer. So if anyone wants any information on that, I'm sure we can get it for you. But code.org is a really wonderful coding program, and I love it. So their hour of code activities are great. They have an app lab that lets you make phone apps. They have an HTML, CSS editor that lets you make websites. They have just a JavaScript editor that lets you make like computer games that kids can play online and share with each other. I really love code.org. It's a great platform, and I totally suggest checking it out if you ever have the opportunity. Oh, and one last thing. It does work with our K through 12 computer science standards. I wrote that on there. That is important. It's really nice because when you look at the lesson plans, it lists out which standards it works with. And I know West Virginia adopted those. So if you are a teacher or you know a teacher, it is great for that. All right.
I think Google, I think, doesn't CS First also list?
Yes, it does. Yes. Thank you for pointing that out. CS First also does that. I don't think TinkerCAD or Scratch does by themselves.
No, I don't think so either. So, but good to know. Okay, so we used a lot of these platforms, a lot of supported platforms, and we ran a lot of these sessions throughout summer 2020. And we learned a lot. You know, we were this was the first time that we had tried doing this. It was on the fly. We were adapting as we went. And here's some things that we learned. So best practices for us. So like Emma said, our club length when we met once or twice a week was either 1 or 2 hours. Anything longer than that, and you just have youth that are, you know, no longer, you're exhausted, they're exhausted, no one wins. It's it's just a lot. So we suggest not running one for more than 2 hours. And even with our 2-hour workshops that we did in July, we provided like a 5-minute break at the 1 hour mark, you know, just to make sure kids were stretching or, you know, getting water, going to the bathroom, whatever they needed. So highly recommend that. Next, we also utilized a lot of our staff and volunteers. So we, during the summer, we have a program where we hire college students and they're STEM ambassadors. And they also helped us throughout the summer sort of run some of these sessions and workshops after we had sort of piloted it in May. And they are, you know, they're usually, you know, they're pursuing a STEM degree and we had them on deck to sort of, you know, monitor chat, because while one club leader is, you know, running the activity or whatever, someone else in chat can troubleshoot, you know, also make sure that kids aren't running wild in the chat, you know, or, you know, posting things that are inappropriate or whatever. Or maybe, you know, someone has left their mic unmuted and they're having a conversation with someone in their household, you know, just various scenarios that pop up due to being remote and whatnot. So highly recommend having at least, you know, 2 to 3 people on per session, 1 person to lead the activity, 1 person to monitor chat, and maybe just a third as standby in case, you know, either person loses internet or something happens, you know, what have you. Emma touched on this a lot when talking about the platforms. Creating a way to archive use projects. They will keep working on them even after the club ends, you know, or even between club sessions. So with our Scratch coding clubs, you know, she mentioned the Scratch Studio. And that's basically, we made a private group and we were the only ones allowed to like add or remove projects, but you can sort of configure settings to set it up however you want. And we, you know, made sure that like, you know, kids were able to see what everyone else was working on and sort of, you know, like be inspired or collaborate, because another cool thing about a lot of these platforms is that you can copy or remix public existing projects. So maybe if someone had made something cool, you know, they could have copied it and made some tweaks and made their own version of it and then shared that back. So alongside archiving projects, it's a great way to showcase youth work. Kind of already touched on that. And like Emma said at the beginning of a session, we would, we'd scroll through the Scratch Studio page and we'd be like, oh, what project should we look at? Or we had kids who were super excited, post the link to their project in chat. They'd be like, like Emma said, do mine, do mine, do mine. Kids were so excited and engaged that, we kind of had to cut them off at a certain point and be like, okay, well, we have to get started with the next topic. So if we have time at the end, maybe we'll showcase some others. And also just modeling that growth mindset, which goes really hand in hand with computer science education just so well, because, computer science naturally, the debugging, you're going to run into a problem. I always like to tell kids, you're not going to program something perfect the first time you do it. And that's okay. It's okay to, make mistakes, you learn from them. It's important to always keep learning. So these are kind of like the 5 big best practices that we've used and have continued to do throughout the fall, spring, and even this summer. So this is,
I want to add before you go too far.
Oh yeah, go ahead. Sorry, Emma.
Oh, you're fine. I just want to mention that with the sharing, it also is a good artifact for evaluation. So you can look at what they've learned and show you can prove where they've made leaps ahead of what we just showed them. So those who would go out of their way to research and check out other coding programs or coding project examples so they could build on it. So it's always great and it's good to see, and it makes you feel good, but it's also helpful and shows that your program is working.
Yes. Yeah. There are always a handful of those kids, right? So of course we had our pre-knowledge survey. We also had a pre-evaluation that we did at the beginning of our clubs. And then we had a parent and youth survey that we did at the end of our clubs. But this is just sort of for May and June with our Scratch coding clubs, a breakdown of the counties that we were able to reach in the state, which was, we hit over 40 counties in the state, which I thought was pretty cool. And this is kind of one of the advantages of doing these things virtually. You have a higher reach of youth, although, the drawback is, you're not face to face, you're not getting that same level of socialization. But, some of these kids that participated in various counties may not have been, if we had hosted it at, say, WVU campus or Jackson's Mill, they may not have been able to travel to attend. So this provided them a lot of flexibility, and it's pretty cool to see because, our highest counties here, we have Monongalia, but we also have Putnam and Raleigh and Jefferson and Kanawha. So it's just really all over the place. And that was super exciting for me to see. I was like, yes, more people in the state. That's awesome. So really love that.
And it would be hard for Jefferson County to get to Jackson's Mill. I know that's a long drive for those folk.
Yep. Living the panhandle life. Something else we captured in our pre-evaluation was how kids felt about computer science, and growth mindset. Did they believe that they could become a computer science? Did they think they were good at it? Would it be interesting to them? And it was really encouraging to see that a lot of them thought that they were good at computer science, and if they took a class, they would fit in with others. So on the flip side of that, also they really showed the growth mindset. With you have a certain amount of intelligence and you really can't do much to change it. They were like, no, we disagree with that. That's not right. Which was kind of cool. So I love this breakdown of how kids view themselves and what they thought and felt about computer science, because a lot of the times it can be pretty daunting to just jump in there and start programming. I know I felt that way when I went to school, so it's cool to see that things are changing. This is also just another interesting breakdown. So a lot of the youth that we worked with were, it was open to 3rd to 12th grade, but we primarily had 5th and 6th graders. Those were our 2 highest, grades. But then the other interesting part is that the coding experience of all these youth, a lot of them had never programmed anything before, not a thing. But they were so excited to learn and ready to just hit the ground running. It was cool. Or, maybe they hadn't used Scratch specifically, but they had done some other, programs, whether it was robotics, code.org, or some other drag and drop programming language. So that was pretty neat. I mean, that's over 200 of the 300 kids that we had in our Scratch code club. I've not programmed much, but I'm interested and ready to go. So, Emma, do you have anything to add to any of this, or?
Nope. I think you did a great job. I love teaching kids who've never coded before. It's such a great experience, and it's awesome. One thing I think that we miss by having it virtually is the kids weren't able to help each other as much as they are in person when you have this. We did still have kids who were like the master scratchers. So you would have them talking in the chat and be like, you can try this and you can try this, but it's just not the same virtually as it is in person.
Yeah, you don't get that pair programming experience. Because I know that's done a lot in person where you break them up into pairs and then have them like work together. Yeah, so that was missed. I agree. That's unfortunate. So after the summer, and we had all these coding clubs and workshops, we were like, what can we do to make this better, or how can we tweak what we're already doing to make it a little less cumbersome? Because, at the end of every week, we were sending out emails to families and participating youth, sending them the recording link, sending them the information for next week. And it was just a lot of, I guess, maintenance. So one of the things that we started using was Padlet. It is kind of like a resource hub, is how we use it. We post our recorded Zoom links there. We also can break everything down by like week. So you can see in the screenshot here, it has like week 1, week 2, week 3. And this is actually a screenshot from a TinkerCAD club that I just finished running in June. So we're still doing virtual summer camps. We're doing them a little different, but, and this is one of the ways. Unfortunately, the Padlet is not accessible with screen readers, which was kind of a big bummer for me. And we have had youth who are, visually or hearing impaired and had to make sure the platforms that we use are accessible to them. So we have tried to keep that in mind and offer either, alternatives, just changing the format of the content that we're providing. So that is something that's in the back of our minds while we're doing this work. But another great thing about Padlet is that you can share extra resources that, your time with kids doesn't allow. Maybe you wanted to show a really cool video, but it's like 10 minutes long, or you wanted to have them, read some blog posts that kind of relates to whatever you're teaching about. Or like for TinkerCAD, since they were designing things, in the 3D space, I provided like project dimensions for them. So like one of the things they made was a bubble wand. So I was like, it can't be longer than this, and it has to be this high. And so that kind of teaches them like project requirements and that kind of thing. But yeah, I really like Padlet. The only thing I dislike is that not accessible to screen readers. So just keep that in mind when working with youth. On the flip side, sorry, that was a bad pun.
It was a good transition, 10 out of 10.
We also used Flipgrid, and this is kind of like, so you make a group on Flipgrid. So this one was for a Mars Base Camp club, which is a kit that we mailed out, and I'll talk a little bit more about that here in a few minutes. But you make a group on Flipgrid, and then you can make topics. So there are the 5 topics there, and each topic for us was like a different week. So like the first week, it was welcome, introduce yourself. The second week, I think, was landing zone surveyor. But it allows you to sort of like create this video forum, and it's really great for sharing like hands-on projects. For example, with the Mars Base Camp, we had them build a rover and like build a little ramp for the rover to run on. And that's super hard to share during Zoom, but with Flipgrid, you know, they could record on their phone, their tablet, a 30-second or a minute-long video, and then post it to Flipgrid. And, you know, everyone could respond or say, oh, I thought that was really cool, or I did something similar. So it allowed more of like that like discussion and sharing that, you know, youth would normally get in person while doing the activity. One of the great things about Flipgrid is it is super accessible. It's able to be read by screen readers. It's very friendly for visually impaired folks. It's awesome. So Flipgrid is really accessible and really easy to use. You can
also for hearing impaired, it has auto captions, which is great.
Yes, that's right. And it also allows you to set up classrooms. You can also connect it to a Google Classroom. So there are a lot of different ways for you to manage a group of youth, or, you know, maybe you wanted to use it with your colleagues. You could do it that way as well. But it just is a good like discussion starter space. And then we've also used a lot of the, well, not a lot, I'd say a few of the videos that have stood out to us, you know, we've used as like artifacts for like reporting or sharing things that we did, that kind of thing. So it's great for that. And then the last thing is that so summer was all virtual. It was all software-based stuff. All of our platforms were, you know, you had to have an internet connection, and it was all programming based. But as we got into the fall and the spring, and now even this summer, we've started mailing out kits to kids. So we are still using our same virtual club format, but now we just send them stuff when they register alongside that. So one of the things we sent out was, you know, our Mars Base Camp STEM Challenge, which you can see pictured here. It had a lot of different components and pieces, but it was 4 activities that kids could do, either, you know, like with their family or by themselves, and it's all hands-on. Another event that we did it with was our code camp, our annual code camp that was in February, and we had so many things to mail out because we had tracks set up for kids, and each track had a hardware and software component. So, you know, if I registered for, let's say, learning how to program in Python, I would be mailed one device. If I signed up for Scratch, I'd be mailed a Sphero. And so that worked really well. And then this summer we've been offering 4 different virtual summer camps. So we had 4 in June, another 4 in July, and they're a wide variety of topics. There's one that's all about like the environment and being like environmentally friendly. There's one that's all about chemistry. There's TinkerCAD. So it's basically anything under the umbrella of STEM. So we've branched out from just being about programming and coding, and have tried to include more STEM variety, I guess you could say. One of the things that the most important thing about mailing out kits, though, is that you need to have a clear cutoff date for your registration and mail out these kits at least 3 weeks in advance. For our code camp, we cut it really close, and then we had like a winter storm, and, you know, it's hard to deliver packages in the middle of a storm. So that's something to keep in mind. You know, there's also the risk of kits going missing and losing, you know, the cost of that. Although thankfully we have not had that happen very much. So it's been a really useful way to provide even more hands-on STEM education. And it has been kind of exciting because, you know, you get to see kids like on Zoom, they're like, I got my kit, and they're holding up this box with all of this stuff inside, and, you know, you get to see them like like, it's like them opening Christmas sometimes on Zoom. You know, they're just that excited about what's inside the kit. So that's been really.
It is so cute. We did a 6-week rocketry club, and it was really adorable because they were like just pulling stuff out, and we were like, "Don't lose any of that."
Yeah, something that I've also started doing with mailing out kits is that since you only need a certain amount of materials for each week. Before I send out a kit, I lay everything out, and I like to take a pic. I mean, just like on the side here, I take a picture, and I'm like, okay, this is week 1, this is week 2, and that keeps it really clear and makes it easy to communicate what kids need.
Katie, that's so smart.
When your session starts.
That's so smart. I should do that next time I do a kit club.
And then you can use it in your reporting and your files for when you're talking about the event you did. You can be like, this is what I used. So it's
so smart. So
super
smart.
So that's kind of where we are with these virtual summer camps clubs. But as we are easing back into more in-person activities, I think we're still going to maintain our virtual presence, again, because it has that statewide reach, which is really cool. And, travel can be difficult. Maybe a parent can't get off work. Maybe, they just have difficulty getting there, whatever the reason. The virtual space still has a unique reach that we want to maintain. This last slide is just some links. I don't know if or where we can share these PowerPoint slides, but this just has links to a lot of the things that we've mentioned. The last one here is Click to Computer Science. And it's all about creating and starting various CS education events in your community, your club, or even on a state level. So it's a really great resource. It's just it's a new site, so new things are being added all the time, and it was started by National 4-H. So.
And if you guys want us to email you a copy of the slides, just put your email in the chat, and we can do that.
Excellent idea. Yes. But that's it. Do you guys have any questions, or do you have anything to add?
If anyone does have any questions, you can, there should be a button to click where you could say share audio, video. You can choose not to share video if you want. And I can let you share audio or in the chat, either way.
Go ahead and just stop sharing.
Well, you're welcome. I had to bring Kiri in. She kept unmuting me. I said no at some point, and then I was like, oh my gosh, she unmuted me.
Yes, so if you want to reach out, I see Emma put her email in chat, but I'll also just include mine in there. If you want to reach out, or if you have any questions about using these platforms or running this kind of event. One last thing I will say is about running these events. We had one session of a Scratch Coding Club where we had about 70 participants, and I would say that it got pretty hectic with 70. So I would not go above 70 participants for one virtual session unless you had a lot of staff or volunteers that could help you manage that, because it can be a lot. Ours were typically anywhere between 20 to 50. Give or take, just depending on the week and who was available. Because we also went back and looked at the views and on our recordings and found that a lot of parents, like Emma said, had their kids go back and rewatch it. And also then, kids can go at their own pace, and it's just a lot easier. So. Awesome. Well, thank you guys for attending, and I'll be sure to email the slides to those who share their email. And again, if you have any questions for Emma or me, just let us know.
And you can even ask us like troubleshooting questions too. We've had teachers email us to be like, "How do you do this thing in CS First?" And we figured it out for them. Between the two of us, we're pretty good at it.
Yes. we've had a lot of practice at this point.
Yeah, we have.
So yeah, awesome.
Thank you so much for sharing with us. That was a wonderful presentation.
Thank you for having us.
Thank you for having us.